So I guess one of the real interesting questions we ask ourselves is, who cares about climate change? And there are really two sets of answers to that. One is that when we use electricity, when we drive our cars, as a byproduct, we put out greenhouse gas emissions. On the other side of the story, those greenhouse gas emissions actually cause climate to change, and then that climate change makes life a little bit more uncomfortable with us. So for an economist, there's a difficult trade-off problem. How do I compare the benefits of creating pollution, that is, being able to have lots of cheap electricity and drive cars, but also I threaten climate change down the track? So we can look at this in a kind of systematic way. At the top here we have the flow of greenhouse gas emissions. So this is where we're producing electricity, and we can have nice air-conditioned buildings, we can have hot water for nice warm showers, this sort of thing. We can drive away for holidays, and that's really beneficial to us. But at the same time, burning those fossil fuels releases carbon dioxide, methane, nitrous oxide, and some of these other nasties. And they flow down into this second stage. They add to the global stock of greenhouse gas emissions. And the pollution that's put out by people in Bangladesh or Australia or the US or Russia circulates around the globe and lasts in many cases for hundreds of years. And that ultimately causes climate change. So then we move down to here, where we have hotter temperatures, changes in rainfall and so on. And that can make life difficult for some people. Our agriculture is set up under the current rainfall and temperature conditions. If we make it a little bit hotter, we change the seasons, we change the rainfall, the farming practices that worked for my mum and my dad won't work for me, and certainly won't work for my kids. Or I make life more challenging for biodiversity to survive. So these are the sort of costs of climate change that we're going to track out. So these changes affect businesses, and so they're very dependent, for example, on transport. And if we have more severe weather events, there are going to be periods where transport is going to be delayed or it's going to become more expensive. Or households, their temperature changes and so on. Governments, of course, they're responsible for looking after a lot of infrastructure, roads, ports, and for looking after national parks to protect our biodiversity. The way in which they have to make their decisions are going to change. And the unfortunate thing is they're going to have to choose options that are not quite as good. That is, I'm going to live in a hotter climate or a drier climate. Or it's going to be much harder to protect national parks. So those are the sorts of changes that we worry about in the costs of climate change. And so if I briefly categorise those, we expect that sea level is going to rise. We expect that the availability of water will be changed, and we'll often have to shift from, say, relatively low cost dam-fed water to higher cost desalination or recycling. The cost of food production, agriculture has to adjust to changing climate. Threat to our ecosystems and national parks. We expect that higher temperatures, changes in humidity are going to affect the way in which diseases can spread around, and we either have to spend more effort in prevention or we're going to suffer with greater disease outcomes. With climate change, we expect more cyclones, more floods, more droughts. That's going to put pressure on our roads, our electricity power lines, our ports and other infrastructure. And of course, we're going to have to change our comfort of living. So how do we set this up as a more kind of formal model? Well, we're going to represent the change in climate by a variable we'll call x. And that might be the average global temperature. So for example, we expect over the next century, if we don't change our greenhouse gas emissions, temperature might rise by say about 3 degrees centigrade. Or we might represent it as the density of greenhouse gas emissions. And so here we talk about CO2, carbon dioxide equivalents, in parts per million in the atmosphere. So X is the change in climate. What we're worried about then is the cost to society, and we'll call that variable Y. And Y might be measured as the loss of gross domestic product, which is in fact a measure of income, or it might be measured as what we're going to have to pay more for roughly the same product. So if we put these functions together, we can think of a total cost function. So what we have here on the horizontal axis is a measure of Y, or climate change. So we might start off here, this is say 2010. The current level of greenhouse emissions is about 400. And if we move up here to say 2100, the end of the century, and if business as usual, we don't reduce our greenhouse gas emissions, it might go from say 400 to between 600 and 700 parts per million. Or we might talk about the average temperature jumping from the current level, which is somewhere around 11 degrees centigrade, up by 3 degrees, up to say 18 degrees centigrade by the end of the century. And on the vertical axis, here, we're representing increasing costs of climate change. So if we stop down here at the axes, no change in climate costs. As we move up here, we lose more and more income. And so we have this function Y is a function of X. As we get higher temperatures or more greenhouse gas emissions, our costs actually go up at an increasing level. So that's what we refer to as a total cost function. The costs of climate change, Y, as a function of measures of climate change. What we'll also find interesting in this course is the marginal cost function. And here we'll be talking about changes in the costs, or changes in Y, depending on changes in climate change. So again, on our horizontal axis, we have here the measures of changes in X, the changes in climate, more temperature or a bigger build-up of greenhouse gas emissions. And on the vertical axis, as we move up here from 0, we have additional costs of climate change. And so the story that we have in mind is, as we get more and more dramatic climate change, the additional costs are going to increase. So we have a marginal cost function that's increasing in the level of climate change. So we're going to use those sort of functions quite a bit through this course. What do we know about some of these measures of climate change? So Nicholas Stern was asked by the UK government to make estimates of the costs of climate change, and he reported in 2006. And he compared a scenario which is really 2005, the world doesn't change, with projections of climate change through to the end of the century. He estimated a loss of national income of between 5 and 20% by the end of the century. Now that's a big loss of income. That's because agriculture is more difficult, sea levels rise, health is much more challenging, keeping ourselves comfortable is more expensive and challenging, and we have threats to biodiversity. William Nordhaus, an American economist, has a slightly different model. He came out with estimates of loss of income of about between 5 and 15% of national income. And what's also interesting, he came out with estimates of the marginal costs, that is the additional costs of climate change for an additional tonne of carbon dioxide equivalent emitted at between $25 and $20. Now, of course, there are lots of estimates out there. And so the economics of climate change, a little bit like the meteorology and the physics of climate change, is we're pretty sure it's going to happen, but we're not quite sure the magnitude. There's quite a bit of uncertainty. So let's put these things back into our graphs. So again, here is the Stern story, where here we've got the total changes in climate change. And we can start here at point A, which is, say, roughly where we are now. There would be no change in climate change. Or we can move up here to point B, projections of where we'll be roughly in 2010, say about 3 degrees warmer, or a jump in emissions from about 400 parts per million to over 600 parts per million. And along this vertical axis, we have our total costs of climate change. Stern said that by jumping from where we are now to where we're likely to be in 2100 if we don't change anything, we're going to lose income of about 5 to 20%. So that's the way we would interpret the Stern measure. And again, the Nordhaus measure is a little bit like that. If we were to go to the marginal cost of climate change, again, we still have on our horizontal axis this X, the stock of greenhouse gas emissions. And let's suppose we are here, this is the current level. On the vertical axis, we have this change in Y, the change in costs. What Nordhaus said is if we keep pumping out emissions now, the cost per extra tonne of emissions is going to be between $25 and $200 a tonne of CO2. So this is one way in which economists try to represent the costs of climate change in making people change their decisions.